Hey everyone, and welcome back to the channel. Ever wondered why when you jump, you always come back down? Or why it is so much harder to lift your heavy school bag than it is to lift a single pencil? It might seem obvious, but the science behind it is super fascinating. Today we're diving deep into three concepts that literally shape our universe: gravity, mass, and weight. By the end of this video, you'll see the world around you in a whole new light. So grab your thinking caps and let's get started. First up, let's talk about mass. Forget everything you think you know for a second. Mass is not how heavy something is. We'll get to that later. Mass is simply the amount of stuff an object is made of. Think about it like this. Imagine you have a small, solid iron ball and a giant, fluffy cotton ball the size of your desk. The iron ball has way more stuff, more atoms packed into a tiny space. Therefore, it has more mass. Everything around you, from your phone to the planet Earth, has mass. Because it's made of matter. The more matter, the more mass. It is a fundamental property of an object that doesn't change no matter where you are in the universe. If you took that iron ball to the moon, it would still have the same amount of stuff inside it, so its mass would be exactly the same. We usually measure mass in kilograms. Or grams, simple enough, right? Keep that idea of stuff in your head, because it's key to understanding our next topic. Now let's bring in the big one, gravity. You've heard of it, you experience it every second of every day, but what is it? Gravity is a fundamental force of attraction between any two objects that have mass. Yes, you heard that right, any two objects. That means you and your desk have a tiny gravitational pull on each other. Even you and the person sitting across the room are pulling on each other with gravity. So why don't you all just clump together? Because the force is incredibly weak for small objects. Gravity really becomes noticeable when you have something with a gigantic amount of mass, like a planet. The Earth has a massive amount of stuff in it, so its gravitational pull is super strong. It's this pull that keeps you, your house, and the oceans stuck to the surface. It's also what keeps the moon orbiting the Earth and the Earth orbiting the sun. The rule is simple. The more mass an object has, the stronger its gravitational pull. And here's another part of the rule. The closer you are to the object, the stronger the pull. That's why astronauts in orbit feel weightless, not because there's no gravity, but because they're far enough from the Earth's center that its pull is weaker, and they are in a constant state of freefall around it. So gravity is the invisible force that plays matchmaker for everything with mass in the universe. So we've covered mass, which is the stuff in an object, and gravity, the force that pulls all that stuff together. Now let's connect the dots and talk about weight. This is where most people get confused, but I promise it's straightforward. Weight is not the same as mass. Weight is a measurement of the force of gravity pulling on an object's mass. Let me say that again. Weight is the force of gravity on an object. Think back to our iron ball. On Earth, it has a certain mass. Earth's gravity pulls on that mass, and the force of that pull is what we call its weight. Now, what happens if we take that same iron ball to the moon? As we said, its mass, the amount of stuff, doesn't change. But the moon is much smaller than Earth and has much less mass. Therefore, the moon's gravitational pull is much weaker, only about 1/6 of Earth's. So when the moon's weaker gravity pulls on the iron ball's mass, the resulting force, its weight, is much lower. The ball would feel much lighter on the moon, even though it's made of the exact same amount of stuff. This is why you see videos of astronauts bouncing around on the lunar surface. Their mass is the same, but their weight is significantly less, making it easy to jump super high. Weight is measured in units of force, like newtons, although we often use pounds or even kilograms in everyday language, which is what causes the confusion. Let's do a quick recap to make sure it all clicks. Imagine you have a 1 kilogram bag of sugar. Its mass is 1 kilogram. That's the amount of sugar inside the bag, and it's the same on Earth, on the moon, or floating in deep space. Now let's talk about its weight. On Earth, gravity pulls on that 1 kilogram mass with a force of about 9.8 newtons. So its weight is 9.8 newtons. If you take that same bag of sugar to the moon, its mass is still 1 kilogram, but the moon's weaker gravity will only pull on it with a force of about 1.6 newtons. Same mass, different weight. If you took it to Jupiter, which is huge and has a much stronger gravitational pull, that 1 kilogram bag of sugar would weigh about 24 newtons. It would feel incredibly heavy. Mass is constant. Weight changes depending on the gravity you're experiencing. So next time someone asks you for your weight, you can be a science whiz and ask, on which planet? Let us think about the brilliant mind who pieced a lot of this together, Sir Isaac Newton. The story goes that he was sitting under an apple tree when an apple fell and hit him on the head. Now, whether it hit him or just fell nearby, this simple event sparked a monumental idea. he didn't just see an apple falling. He wondered, why does the apple fall down, but the moon doesn't? He realized the same force that pulled the apple to the ground must be the very same force that was keeping the moon in its orbit around the Earth. The moon is constantly falling toward Earth, but because it's also moving sideways so fast, it continuously misses it, resulting in an orbit. This was a revolutionary concept that unified the heavens and the Earth under one single law of universal gravitation. It states that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. It's a bit of a mouthful, but it's the mathematical backbone for everything we've discussed today. So, how does this all apply to you in real life, besides just jumping? Well, think about launching a rocket into space. Engineers have to calculate a rocket's mass and the massive amount of thrust needed to overcome Earth's powerful gravitational pull, its weight. They need enough force to achieve what is called escape velocity to break free from Earth's grip. When you're on a roller coaster and you go over a big hill, that stomach in your throat feeling is your body experiencing a momentary change in its apparent weight as you briefly accelerate downwards, almost like a mini free fall. Even something as simple as playing sports involves gravity. When you throw a basketball, its path is a perfect arc, a parabola, because of the constant downward pull of gravity acting on its forward motion. Understanding these principles is the first step to understanding everything from how planets form to how black holes work. To sum it all up in the simplest way possible, mass is the measure of how much stuff is in an object. Gravity is the attractive force between objects with mass, and weight is the measurement of how strongly gravity pulls on an object's mass. Mass is the cause, gravity is the force, and weight is the effect. They are all connected, but they are not the same thing. Hopefully, the difference is now crystal clear. You've just leveled up your physics knowledge big time. The next time you pick something up, you can appreciate the cosmic forces at play. Thank you so much for hanging out and exploring the universe with me today. If this video helped you understand gravity, mass, and weight a little better, please give it a big thumbs up, it really helps the channel. And if you haven't already, hit that subscribe button and ring the notification bell so you don't miss our next science adventure. Got any questions or ideas for future videos? Drop them in the comments below. I love reading them. Until next time, stay curious.